I hope you hear me well, and really happy to be here. Very privileged. So I'm based in Finland. As Rahul said, I'm a research team leader in VTT, which is a technical research center. So we are very much into research projects, and I'm a team leader. My team is very much focused on quantitative methods to analyze science, technology, innovation studies. And then obviously, because when we talk about science technology, we are eventually looking at a lot of textual artifacts. Our knowledge as a human species is very much documented. So then definitely one of the top of the shelf models we use is natural language processing, and then very lately NLP and LLMs, large language models, and AI eventually. So I have crafted like a slide set, and I hope that it is informing and engaging you. Okay, so yeah, I'm looking at this topic of role of generative AI in the knowledge discovery, and with that, opportunities and challenges. So the first premise is that these tools are very powerful, but then again, if not used correctly, then they are also offering a lot of challenges. So that's why it's good to look at them from two perspectives: that what we can gain from them, but what we need to be aware in order to not get lost or kind of not achieve our targets with either research or knowledge discovery as part of the research process we want to do. A bit of my background. So Rahul made a very humble presentation, but yes, I have kind of roles in academia and industry. Via VTT, we are also working with corporate clients. So I hope that I'm having this approach of what is happening in kind of science technology like academia, and then what is happening in the business sector. So this combination would probably something that I hope that I can convey. Then otherwise, I'm also very active in LinkedIn and have my blog post series. So if you would like to follow me there and continue with my community there, so please be in touch there as well. But without further ado, I think this is a good exercise that we also get to know each other. I would like to also know like what type of audience is there, and what is your way of looking at this thing in the beginning. And I think it's also an interesting exercise for others who are in this session as well. So the Mentimeter is something that you can also find in internet. Like if you type menti.com and then there is a code. So this is like a very simple question about what you position the added value of AI in scientific research practices. Yeah, just please either navigate with the QR code if you are able to use your phone, or then go to the menti.com and type the code. This is just, we would like to understand as a crowd how we would position ourselves, especially when AI is very much available for doing scientific research practices. So I think the very big questions about to what extent AI really improved efficiency of our research processes. Do we really see that it has a low impact, or it has achieved a high impact, or do you also evaluate it on another spectrum, like is it a low innovation or a high innovation? I keep the responses to come so that we can also see at the same time how the kind of responses are clustered. The other interesting question is that how much has AI enhanced the accuracy of your research outcome? Do you value it very high impact or high innovation, or the other way around? And then the last one is, how significantly has AI contributed to productivity of your research team? And this very much looks at your collaborators, people who you work with in your teams, your colleagues, your co-authors. So how you would expect that AI has contributed to the productivity of you as a team? Quite interesting. I mean, now what I see is that it is quite relatively high impact and high innovation. So for all the three questions, and I have to be honest that in different setups, in different audiences, I have tried this in the past couple of workshops that I have organized. it really varies. I mean, in disciplines, when you go to different disciplines, you see that people have different opinions. But yeah, I think that this crowd is very much, I would say, optimist in a way that we are expecting to have high value and we're getting it. And then, of course, high innovation is also part of it. But interesting, I would go further in my material and I try to kind of show you the other side of the story. How should we be more careful, not necessarily using the word pessimist, but how to be more responsible. And I would dive a little bit deeper to the challenges that we would face. So maybe kind of going through major trends. I think you're seeing a lot of fuzz and buzz around AI. Of course, these are tools driven by profit-making companies, so they are really putting so much effort to make us believe that, okay, these are something that really are changing a lot of stuff, to some extent true, but again, it's really hard to navigate that, okay, what is real innovation, what is substantial, what is moderate. So I try to kind of get a hang of it, like go around it and then try to cluster it into major, let's say 7 categories. So one aspect, which is like we keep seeing in a different form and shape, is that these models are getting cheaper and then faster. So in a way, it's a good thing. Necessarily not cheap. I mean, we know that these AI models are quite expensive to operate. They are very energy hungry. But then again, when it's very early in the process of adaptation, we see that companies are very much competing with each other. So we are somehow in the honeymoon phase of like competition and then discounted prices. And then, of course, this other aspect of efficiency with engineering. So these models are also trying to organize themselves in a different way. So this engineering aspect to make them more efficient and faster, again, is another criteria that we are all observing. Then we are seeing that, these large language models, the core functionality we see behind, for example, ChatGPT or any AI chatbot, they are getting more capable. For example, one of the limitations have been always this context window, that how much material you can send to the model for the processing. But this is also increasing. Now, Google Gemini has claimed to have 2 million tokens, which things used to be like, if you look at 2 years back, the context window, which is very kind of a big aspect of utility of these models, were much, much shorter, meaning like 16,000 tokens, which you can barely even put like a article. But now with imagining like 2 million tokens, you can eventually offer your knowledge, the knowledge that you want to have some analysis with in a realm of like 50 or 200 research papers. The other trend is on-premise AI. And this is mainly because of the concerns about data privacy and data security. Obviously, I mean, the tools that we are using nowadays are very much cloud-based. You can barely have anything on your local machine. And if any, it would be very inferior. So if you're willing to use these very advanced models and get very high-level qualities, then therefore you need to use cloud. But then that comes the question that, okay, then ownership of data, that when eventually you put some data in the cloud and send it, for example, to OpenAI or whatever provider, then data is basically gone. So then in cases where the data sensitivity is a matter, as an issue, then there is a trend that, companies or the ones who would like to try these things are going to acquire machinery and, the servers and the tools to run it in-house and kind of locally. Then about this restricted versus specialized AIs, which we also published recently about this topic, that, not for everything we need like these very generic large language models. The things that are available to us via, for example, OpenAI, they are there to serve generic purposes. But then imagine that if you have a very specialized application, for example, you want to use it for topics on biochemistry, maybe there is an AI that has been trained on a better data. But if not, then there is a path that you can actually create your own large language model and then use it for your own purposes. So then it comes about that the kind of the trend is going more to the direction that, instead of like very large and universal language models. We are expecting to see much more specialized and then fine-tuned models for very particular tasks. Then the other trend is about the open versus closed models. And this is rather interesting because what we are seeing nowadays, at least the very good ones, they are owned by companies with commercial aspirations. So then the diagnosis or kind of understanding the parameters and then kind of knowing how these things are functioning is very challenging. However, the open source community is offering a lot of kind of nuances, and that's why it is also helping the progress of other application of this model. And this gap is closing, which is in a way very interesting pattern. It used to be that the best models you could see from the commercial providers, then there was a lag of 1 year so that you could see something equal from the open source community. But now this gap is almost closing to less than 6 months. Then one other aspect we are observing is this combination of different AI and then AI models and then forming agentic approaches. So in a way, using in a very creative way, combining different agents to do a particular task. And I have an example. I will walk you through how I would use it and how we would use it to facilitate knowledge discovery, summarization, and getting understanding about certain trends. And then last but not least, it's about evaluations. Evals and basically large language models evaluation is very critical because obviously what you see is that these are machineries that are predicting some text. But then the question that, okay, to what extent we can rely on the intuition or the responses that these models are providing. The reality is that in this chart, you can see that the human evaluations, they're very expensive. So we as humans are rather slow. And then for certain topics, we don't even know. We don't have the knowledge to basically evaluate if these topics are valid or not, if the responses are accurate or not. Then the ground truth, the factual things are also really hard to collect. Again, there's like a lot of unknowns. But then we are seeing this trend that LLMs are getting more functional and they're getting more equipped with different type of other mechanisms like reasonings and logic imitation. And then the multiplicity of these LLMs eventually are creating this realm that LLMs are evaluating each other. And this is a trend we are going to see more and more, that evaluations are also outsourced out of the human realm, mostly to the LLMs, and then eventually humans are just part of the loop. And then I think I don't need to emphasize on this that earlier there wasn't much research about the productivity and utility gain of using these tools for work, but consultancies have done very rigorous type setup studies. In this case, BCG have done a study that they provided AI to a certain consultant and then not provided AI to another one, and then they were about to do the same task, and then they realized after that that the ones who were offered with AI tools and they were able to use them efficiently, they were more productive by even 40% percentage point, which is like very substantial. So then I think the clear message is that definitely there are productivity gains. If you are able to know how to use them, you are able to be more productive from your peers comparatively to your counterparts. And then again, in science, I think one of the beautiful things that happens with large language models is that this democratization of participation in science. I mean, in a world that we are now living in, 95% of the population are non-native English speakers. I think majority of these audience probably to an extent. So leveraging these AI tools can definitely help to bridge the language gap. I mean, that itself is a very interesting step forward, that eventually we now have tools that are able to kind of make discussions more robust, more diverse, more innovative, and then basically the language doesn't become a barrier for non-native English speakers to kind of communicate their thoughts. And I think we all have seen, if you have ever published a paper, immediately if your name is not like a Latin type name, it's very much obvious that you would probably be asked to do a proofreading And these are costs. I mean, no matter if you have done a very good job on communicating your research in a paper, but then again, there are like these kind of matters that their reviewers or editors are expecting you to do the proofreading. But then again, we see that these tools are very efficient with proofreading, and it's become evident that there are many use cases of that as well. But on the other side, I think there is another aspect about this not being responsible on using them. So, and this phenomenon of like, generative AI filling up internet, I think that's also very alarming. That nowadays, I think there was also a report about the quality of search engines. Nowadays, it's also really hard to get something out from the search engine because, well, thanks to generative AI, there's so much content generated over the past 2 years that it's making it difficult to basically index and search and find relevant information. And that's a challenge itself. I think it's very fair to say it's like a data pollution in the realm of AI. And we're also seeing it in the academia. I mean, it's not only internet, but this pollution has already penetrated our scientific discourse. I think you have all noticed in social media and LinkedIn or elsewhere that these papers that, for example, forgot to take out the bits and pieces that you, for example, normally get out of ChatGPT, and then somehow the review system didn't notice it, and then they were published, and later people understand that, okay, well, even in the abstract, there is this thing that ChatGPT used to say, and the authors forgot to take it. But again, I mean, this is like just the tip of the iceberg. I mean, you can even try it yourself. Like if you go to Google Scholar or any kind of scientific indexing engine and search for these kind of common phrases like, unfortunately, I'm unable to answer your question that GPT sometimes give, or that I'm sorry, but I don't know, blah, blah. You see that there are actually papers who have mentioned these things, and they are still listed and nobody have noticed them. But again, think about it. This is only just the tip of the iceberg. These are the ones that have forgot to take these out, let alone the ones that have used it, and then they were kind of careful enough to go and check and take them out. But that is an indication that, AI has already penetrated our writings, and it's already in the scientific discourse. And then the dilemma comes that, okay, do we trust? I mean, should we trust the authors who have used these things, have really cared about what they are communicating, or have they really proofread and checked what AI is giving, or not? They were just using it, and they didn't even care enough to read it again to take at least these very obvious phrases. So I think this really kind of shakes the trust foundations of scientific discourse. There has been also studies that people did by very simple kind of text analytics. They realized that there are certain terminologies that suddenly start to spike only after we ended up having, for example, ChatGPT type tools in our availabilities. For example, these words like delve or tapestry or vibrant suddenly start to grow after 2022, exactly when we start to have ChatGPT as a writing assistant. Or then other kind of very much overused ChatGPT phrases like dive into, it's important to note, suddenly they start to rise. And these are all indication that there are, I mean, authors are using it, researchers are using it, and that itself gives us the impression that, okay, next time we are reading an article, should we kind of really trust this thing, or is it an AI written thing? I think I always have the dilemma, and I'm always getting more skeptic about when I'm reading a new article, because you obviously think that, okay, it's great, it's a very productive tool, but again, if everybody's using it and they're not really taking care of what they're communicating, maybe it's a big problem. Yeah, I mean, the researchers are just publishing nowadays that GPT writing style has infiltrated over 10% of scientific abstracts since its launch. They're also identifying what journals are more visible, what countries, and so there's like a lot of the statistics are coming around. So it's really there. we are basically in the area where AI has penetrated and polluted our scientific discourse. But then again, I think that the easy solution to overcome this kind of obvious word replacement to something else, so not to be detected, is maybe like next time you're proofreading, use an AI to make sure that you tell it that don't use delve or this and that, and then it uses a different word. But then does this necessarily solve the problem? I mean, we all constantly keep using that, but then the language keeps changes, and I think nowadays even you don't see much delve within ChatGPT, because I think they have also fixed it so that it doesn't sound like all the time similar answer to everybody. But then I think the biggest challenge here is that the speed of content production is at ever high, and that will cause certain issues. Most of all, like this rapid generation of falsehood. So we know that LLMs like chatbots, they are not able to understand the kind of the truth, and then at the same time, if this ratio of creation of content is so high, basically if we affiliate it to creating a falsehood, then the human capacity for correction is very, very kind of limited. I am actually functioning as a editor in a journal, and we have already noticed that there has been much more submissions to our issues, but at the same time, the editorial board is the same number of people, and then we have also the same number of hour and capacity to perform. So in a way, this is like very much an unfair battle, like human versus AI, while authors are using huge load of these tools, and then the increase of submissions. At the same time, the review system is also suffering because they don't have enough human capacity. The other problem which might emerge is this amplification of lies. So in the digital era, in a way, if something keeps just repeated over and over again, in a way, it becomes like a fact. And this is also like a very much risk, especially in very sensitive topics like healthcare or pharma, that it's very much deals with humans' health. So imagine that if some research comes out with use of AI and not responsible use of AI, and then it becomes like a knowledge, and then everybody tries to cite that thing, then eventually we are proliferating these kind of non-factual information into the discourse. And then it will end up in a vicious cycle, because if you recall, these LLMs have been trained on information or accumulated information as human species, like whatever has been on internet, the books, the research articles. And then suddenly, if now we are in the era where LLMs are producing so much content, then the next generation LLMs will eventually train themselves on these falsified, non-relevant and non-very representative information, and then the quality of the future generation LLMs will definitely suffer. So this is very much like a challenge ahead, and I wanted to raise it to you that okay, these are great tools, but at the same time, if all these tools are available to the majority public, and then people are not really understanding the responsibility of using this, then we are actually crippling ourselves and then creating much more problem later in the process. And this is like, again, everywhere. There was earlier like a Nature article came out that they also identified that reviewers are also using generative AI to review articles. And this was in a very particular conference that they realized that, okay, 17% of peer review were kind of having significantly influenced by AI. So in a way, we are in a world that eventually AI is writing papers for other AIs to evaluate. This itself is very kind of thought-provoking and in a way scary. So, where this tsunami of AI-generated content is going, I would say it's really hard to really, at least for myself, to wrap my head around. So there's like this evolving threat of data pollution. We discussed about it. Search engines are also suffering from it because they are working with these SEO tactics and these keywords ranking and all. So eventually, if these content is much more, then they will suffer. So we will end up having more problems identifying and finding relevant information. The search reliability will definitely reduces. So we will get like a lot of these influx of low quality AI generated content where it's really hard to kind of work it out with the search tools or search functionalities to get out. And then in the most kind of technical and critical discourses like scientific discussions, it becomes much more sophisticated because AI is very good at communicating and argumenting and then identifying that, okay, what has been written by AI or not, it becomes even much of a bigger challenge. And if you remember, like OpenAI, even when they announced their tools, they had like an AI checker. But then they really pull it out because it wasn't working. I mean, in a way, it doesn't, because it's so convincing that it's really almost impossible to identify if something has been written by AI or not. So I think, in a way, I would like to also invite you to think about these thought-provoking items that I have listed here. So in a way, it's a double-edged sword, reflecting on LLM impacts. So there's a topic of ethics in AI. We have to get ourselves comfortable with the fact that AI decisions hold ethical implications eventually, and then how we would like to align them with societal values. So as AI, these LLMs are becoming more fluent and more functional, and now AI agents are there. Eventually, we would see them coming into our societies, into our systems. Imagine whatever it could be, like about the social welfare type of allocation of like certain resources to an individual, or even when you're applying a job, like an AI screens the CVs and resumes. So what about these kind of AI decision making? To what extent do you want to really outsource these type of decisions? To what extent we would like to be in place, kind of making sure everything is in order as humans? And eventually these systems are getting complicated, but how we should design these systems that humans can still be on board. Then the bias in AI, we know definitely AI will inherit bias from the training data, and then how we can prevent that, that's another question. The other aspect is about dependency on AI. We are eventually relying more and more on LLMs, and this will eventually result into our cognitive capabilities being diminishing. And this is a research also has came that the coders who have been able to write codes very fluently, nowadays they are actually suffering because they have been outsourcing a lot to LLMs, that their cognitive capability and their ability to write a functioning code has reduced because they have created a lot of dependency. Misinformation, I think we talked about it. It's really hard to identify what is real, what is not. And especially when it comes in a very, certain type of dialogue, like in the scientific papers, it even becomes much, much more difficult. Content authenticity. And then last but not least, this collaboration versus isolation. I mean, we are seeing that LLMs becoming, well, these AI tools becoming very functional. So imagine as a scholar, you want to do something, and you might eventually go to your colleagues and ask for their help. But now when AI is available and you can, for example, do coding without knowing much code, then you're probably not going to go to your colleague who is very good in the statistical analysis. So in a way, it is putting ourselves into our echo chambers. In a way, we end up in our silos and working with our own AI models and AI chatbots, and this will somehow suffer the collaboration. And in academic literature, this type of tools we are seeing over and over again, that it's becoming very mechanical nowadays, for example, to get in a state of art understanding about a certain topic. So we are seeing more of these machineries coming, and the caveat here is that the distance of a scholar to the actual data is becoming much further. So in a way, you're having these machinery to do a literature review for you, to identify state-of-the-art gap analysis, and then whatever you end up looking at is something that AI has decided or AI has kind of curated for you within that very complicated process that eventually you are not really familiar to go and diagnose and see what can be fixed. There are like a lot of tools out there such that, and this is one example that probably you have used it, to do a literature review or to find a support for an argument for your paper. But again, I would like to raise your attention that, these are not, again, comprehensive. You need to pay attention that what type of data these models have access to. I mean, the whole world is around 400 million publications. So if you're using, for example, some of these claim to be chat tools for scientific literature, you have to realize that a lot of the content of publications are copyrighted material, and they are behind these major publishers like Elsevier, Scopus, Springer. So they are not so available for these tools so that they can retrieve. So whenever they are claiming that they have these most comprehensive, I don't know, whatever literature review or AI research chatbot, you have to realize that this is only have a very much fractional amount of full text papers in itself, and that's no way even close to the 10%, because the only thing they are able to kind of get their hand around is open source publication, nothing else. So then next time when you are looking at these things and getting some sort of input, I mean, it's a good exercise. You can probably get some nuances that you have not considered, but be aware that when you are querying these things and you're interacting with these things, they're only able to give you some probable 10% of the population of all the scientific publication in a form of reference, or that's what they have access to. And then this is also varies heavily with disciplines. Some disciplines better coverage, some low coverage. So again, I think this is something to consider. But then moving on to the responsible use, I have really put a lot of emphasis on the challenges that not being responsible user can create for using these AI models. But then maybe some insight about the responsible use cases. I mean, we of course know that there are like many of these top LLM providers that are very kind of aggressively advertising, and they are having this capacity and engineering and the machinery. So, but then at the same time, when we are looking at LLMs, there are more than 15,000 LLMs out there, and ChatGPT is being one of them. I mean, OpenAI has like around more than 30 models, but they only have 30 models out of that 15,000 LLMs. So this is very much to identify the kind of the issue that these LLMs are very much data specific. So they have been trained on a very particular data, and then therefore they are kind of showing a certain capability on that. So then, for example, if you have a very particular application, you need to go and look for that LLM that has been trained on that particular data so that you can get a quality response. Otherwise, you would not probably get the quality response because you don't know if this LLM has been trained on that data or not. And there's a lot about these evaluations. I mean, we talked about it. I had a slide earlier that it's not about just an LLM kind of responding to you in a very human sound type of a interaction. It's more about, okay, what type of knowledge they have. There are certain benchmarks, there are certain evaluation systems maintained by scientists, maintained by other open source users. So it's really important to also get yourself familiarize how to benchmark LLMs for your own specific application. For example, if you're using LLM on a healthcare related matters, you need to go and check which one of these are performing better on those tests related to the healthcare information, or which one of them have more information about, for example, health related content that they basically inherit that in their functionalities. Otherwise, LLMs are kind of empty boxes. They are definitely bound to their training data. So if the training data is flawed, then you are expecting that to have a very kind of flawed application. Not to surprise you, I mean, there is this community of flat earthers. Like, there are people part of the world that they believe that Earth is flat, and they have made an LLM. They have collected all the evidences that they believe it actually corresponds to that matter, and they have made a language model that eventually, when you talk with that language model, it tries to convince you that, yeah, indeed, Earth is flat. So that's kind of shows you the fact that you need to check what data these models have been trained on, what type of performance they have on evaluations, and therefore use it for the application you're looking for. There is this clock 10-10 phenomenon, and I think this is a nice exercise. I also invite you to go and try it yourself. Try to prompt your language model, ask it like, draw me a watch shows, I don't know, whatever time. I mean, here I just put 5:15. It gives you a watch that shows like 10:10. So, and then if I try to prompt it again and say that, okay, well, work harder, this wasn't correct, give me a time watch that shows 5:15, again, it fails. And then you start to wonder that, okay, why this is the cause? Well, why this is the case? I mean, this sounds to be very simplistic kind of instruction. But when you just Google it, because again, these models are bound with training data. So they have been trained on a certain amount of images of clocks so that they can actually generate a clock in different positions or different surfaces, like on a table, on a wall, whatnot. But then if you Google it, just put clock in the Google search, you see that all these clocks, or majority of them, are showing like 10:10. I think for aesthetic reasons, some designer decided that, okay, in order to present watches, it's good to show them like that. But then I think this will indicate the fact that these models are heavily bounded to their training data. And then if the training data is flawed, then you see that the use case is also flawed, as we saw it in the example, that whatever you type for the time, it just gives you whatever it has in the data set. And this is just one example. Just extrapolate and try to relate it to whatever other topic that these models might not have the right data so that you can actually query them. So the landscape of science technology discourse in the lights of LLMs. Yeah, I mean, we talked about it. There's so much content is coming out there. 1 million tech-related articles publishing each month. There's 3 million patents filed every year. 2.5 million scientific papers published each year. So this is like the chart is just growing. Everything is just growing in terms of content production. And that becomes very challenging, because eventually, if you are looking for knowledge discovery, you want to identify certain information, then you are basically having a hard time to identify what is relevant, what is not. And this is the global map of science. This is almost 400 million papers out there. They are talking about different topics, and this just keeps expanding, while at the same time, the challenge of identifying relevant information becomes much more challenging as well. Gladly, I mean, with the LLMs, we have certain methods that we can actually use them for our own purposes in a better way and better kind of functionalities. So LLMs being a model that can understand language, can extract context, and comprehend the language. One can actually use their own documents and then use these other type of arrangements called like these RAG applications, like retrieval augmented generation, that in a way you can provide your own knowledge, the approved knowledge that you believe that this is basically what you would like to work with, and then use LLMs on top of that knowledge for your own purposes. One of the also growing application, and I was talking earlier with on a seminar with Elsevier, that knowledge graphs are also coming into perspective. That the data that is out there, it has like certain representation. I mean, they are all have like real world entities. There are objects, there are events, there are situations. They're not necessarily just syntactic things. So, for example, if you just type a Steve Jobs, it's not just the name. It is a person, former CEO of Apple, an inventor of a product. There is a successor to him. He lived in a certain location. So all these data, metadata, is also valuable for the search kind of functionalities. And these knowledge graphs are something that are coming, and it tries to connect these interlinkages, create more descriptions for these entities, and as a result, improve the search functionalities. And now we are seeing that LLMs are also coming into place, basically getting help from LLMs to extract metadata in order to enrich these knowledge graphs, is something that has become very functional. And for example, I mean, think about it. The scenario in a very traditional search engine case is that you might search for deep learning in healthcare, but then this will struggle with synonyms, acronyms, all the semantic nuances. So then, as a result, this information overload will happen. So the results will lack any prioritization. There's not much meaningful organization. So there is a disconnect. So you are looking for something, but you're not getting a very representative answer, and it's really difficult to identify relationship between contexts around these papers. But now when the knowledge graphs are there, and then with the help of LLM, we can actually process much more complicated queries. For example, one can write that what are the latest breakthroughs in AI for cancer diagnosis. The LLM basically interpret that to like latest breakthroughs from the query to prioritize publication from the recent years. And then it also recognizes that when it's said AI in the query, that means actually artificial intelligence and other things affiliated to it. And then at the same time, with the knowledge graph roles, we have identified earlier like articles that are connected to cancer diagnosis or other type of AI-related methods like machine learning or image recognition. So all these linkages are established. So then finally, when you are making a search in such a system, then you will get much better ranked articles. In a way, it's also visual, and it really improves the search quality. Even we have used it at VTT. I mean, in my team, we have used it for example, identifying innovative activities from the company websites. So this is very much like, if you look at company websites, they are not structured as articles or papers. So then you would question that, okay, how to make this process a bit more structured. So we had this machinery and methodology to kind of work with the data on the company websites and then try to use LLMs to create this ontology and then create a knowledge graph. So at the end of the day, we were able to, for example, identify that, okay, this web page of a website, it is disclosing like a innovation about, for example, in this case, new electrode systems, and this has been developed by VTT, like us in this case, and another university, and then the product is trademark named this Polar Electronic. It's like a wearable watch. So I mean, in a way, this is much more intuitive, and this has been achieved by very much minimal training of LLM, applying some historical data and then extrapolating its capabilities. Or in another way, we were able to identify that, for example, what VTT is located and with whom we are connected, who has worked with us, and what type of collaboration has happened, and so on and so forth. Okay, I think my time is almost up. I don't want to take much of your time. I think there might be some Q&A. So then on that note, I would say, Rahul, if you want to kind of open the Q&A, we can move there. I had a bit of more slides. Like, I don't know how much time I have, Rahul. Can I still show a couple of more?
Yeah, you can use your time. Yeah.
Okay,
we
perfect.
can extend 5-10 minutes. Yeah.
All right, brilliant. I wanted to show you this. I talked earlier about this human and AI agents. And I mean, this is coming very much into our use cases. So nowadays, anytime you would like to do something, just try to ask this question about yourself. Can this task be managed by or somehow augmented by AI, or how can AI assist me here? And this question, when you ask, then you realize, okay, maybe there are ways that I can do this more efficiently. And I asked the same question. For example, there's like now, I have this reviewer tool as a GPT function out there. It's in the GPT App Store. That simply I put the reviews that I have done for the papers in my field in science, technology, innovation, and then I compiled this very polite type reviewer that can give feedback on a research proposal, suggest like enhancing or kind of do a friendly review in a much scaled way, even without me being aware. So, I mean, this is nice productivity, I would say. I mean, this could give like some initial insight to an author about how they can improve. Or then another way, these kind of AI agents in action, for example, to identify certain insight. So in this case, I have combined these AI agents into different arrangements that, for example, if you're asking that what are the latest trends in AI, it goes and searches the internet, scrape the content from the, let's say, top 500 links, and then creates a summary out of them. This is, again, something that I'm building with AI machineries, like, AI APIs and things that extends the designing capability, and therefore you are able to do it. It is not so available, for example, if you ask it with ChatGPT because they are also somehow made a predefined amount of, like, for example, capacity that you can utilize them. But with the APIs, you have all the freedom to use them in the extent you like, and therefore you can actually build much more power type applications.